Hi everyone. This is Electrolytic Stoichiometry. These are questions that bring mass or possibly even concentration into the mixture in combination with current and time. It's a style of stoichiometry question that is going to incorporate Faraday's law into it. Our first step is to write the half reaction. We don't need to spend time making a list or any of that. Based on the description provided to us in the question, if we read carefully, the half reaction, we'll be able to figure it out. We can even look up the half reaction in the data booklet. After that, we're going to find moles by using one of these three formulas: mass over molar mass, concentration times volume, or possibly even using Faraday's law. Most of the time, it will either be mass over molar mass or Faraday's law. The concentration times volume formula will show up once in a blue moon, quite rarely. After that, we're going to multiply by R over G. For sure, one of those two, the R or the G, is going to be the electrons. And our last step is to solve. If we're being asked for the mass, our last step will be to multiply by the molar mass. Sometimes we'll solve for the current or the time. Here's an example. If 12.2 grams of zinc are plated out at the cathode when a current of 5 amps is applied to a zinc nitrate solution, then how long in hours did the plating take? Let's look at that. As soon as you see mass, if we're given the mass or asked for the mass, if there's something about mass in the question, it's stoichiometry. It's not just a one-step Faraday's law question at that point. We're going through this whole process. Okay? Our first step is to write the half reaction. Let's read carefully. This mass of solid zinc is plated out. Plated out is a new phrase for us. It means it's produced. It's collecting at the cathode. We applied an electric current to the zinc nitrate. We started with zinc nitrate. We made zinc. We want to write out the half reaction for that. In addition, this question kind of nicely lets us know that this is at the cathode. What happens at the cathode is reduction. We're talking about zinc ions getting reduced at the cathode to produce zinc. I need the half reaction there. There it is. I could find that half reaction in the data booklet. If I feel comfortable enough just working it out on my own, fantastic. The good news is, if by accident I had the correct half reaction but backward, we should still get the correct answer. So we have that half reaction. The next step is find moles. Only one of these options is going to work. Okay? And we have the mass. So that means we can do mass over molar mass. If by accident I tried to, I don't have a concentration or a volume. We do have the current. It's 5 amps, but we do not have the time. We don't have that time. We're trying to find the time in the end. How long did it take in hours? So I'm going to find moles, mass over molar mass. We have the mass of the zinc. It's already in grams. That's good. 12.2 grams over the molar mass of zinc, which is 65.41 grams per mole. We can find that on the data booklet if we need to. Okay, look on the periodic table. Next step, multiply by R over G. One of those two is going to be the electrons. Look at what we have. What was given to us? We know something about the zinc. What we're going to need in order to solve for the time, because it's based on Faraday's law, that's the moles of electrons. So in order to find the time here, what I'm required to figure out is the electrons. So here, the electrons are the R2 over 1. Let's say that in a different way. If we're using the mass formula in our second step, if we're beginning our calculation by doing mass over molar mass, it means that the electrons were required. In contrast, if we were using Faraday's law in the first part, then the electrons would be the G. Moles of electrons would be given to us. After we multiply by R over G, our last step is solve. This particular question says, how long in hours did it take? We're trying to find the time. The time is the moles, which we have represented on the board already, multiplied by F over I. So I'm going to multiply by F, Faraday's constant. That's 9.65 times 10 to the power of 4 coulombs per mole of electrons over the current are 5.00 amps. And I can calculate it. 12.2 over 65.41 times 2 over 1 times 9.65 times 10 to the power of 4 over 5. $7,199.51077.8. This answer, because it's based on our work with Faraday's law, is in seconds. If the question simply said, how long does it take, we would stop. However, because the question specifically says, how many hours did it take, we need to convert these seconds into hours. That right there is seconds. There's 3,600 seconds in an hour. So I'm going to take this raw answer in seconds and divide it by 3,600 to convert it into hours. Divided by 3,600 equals 1.999864105 hours. There's our raw answer now in hours. We need to worry about our significant digits to finish it off. Back to the question, 12.2 grams, 5.00 amps. Those have 3 significant digits. I need to round off my answer so that it has 3 significant digits. 2.00 hours. The possibility exists for us to have stoichiometric questions that incorporate Faraday's law into it. What's going to separate a regular one-step Faraday's law problem from a stoichiometry problem is mass. Yeah, okay, concentration possibly as well. However, most questions by far something about mass. If mass is given to you in the question, or the question asks for the mass, that's 100% guaranteed we have a stoichiometry problem at that point. We're going to get the half reaction. No more of this making a list, finding the strongest oxidizing agent, or any of that. No. Go straight to the half reaction. If we read carefully and interpret the question, that will lead us to the half reaction. We might need to look it up. Maybe we can figure it out on our own. Then, after we have that half reaction, we'll find moles using one of these 3 formulas, multiply by R over G, where, as we previously mentioned, if we have this formula first, then the electrons are the G. However, if we use the mass formula first, like this example, the electrons were the R. 2 electrons, and there's that 2. Then we'll solve. Most of the time, we're going to be solving for the mass, the current, or like this question, the time. Pay attention to what's going on with the time. If we're using Faraday's law initially, we need to make sure that we have it in seconds. And as a follow-up, we need to just read carefully and make sure that we're answering what the question is demanding of us. I hope that helps.